Hi everyone, are you ready for your science for today? Today's lesson is going to be on volts, but before we start, you'll need the following. You need a ruler and a pencil. You need something to write on and something to record, so pen to do your writing. Okay, once you've got that, I hope you're ready and let's get started. Today is Monday, 11th May 2020. Our learning intention is to observe and explain the effects of differing voltages in a circuit. By the end of this session, you should be able to draw a circuit diagram indicating the voltage. You should be able to explain the effect of increasing or decreasing the voltage on different parts of a circuit. Current and voltage. Current is the steady flow of electrons. It is measured in amps, and voltage is the force that makes electric current flow and is measured in volts. The greater the voltage, the more current will flow. If you look at the electrical appliances, you will see a number next to a capital V indicating how many volts the product is designed for. The term volt is in capital because it is a person's name, and the person was an Italian scientist by the name of Volta. Voltage and volt are different. Voltage is the pressure and volt is the unit we measure the pressure in.
To make a current flow, it needs a push from an energy source. This push can be either from the mains or from batteries. There are two main layouts of circuit, series and parallel. A series circuit is the simpler of the two. All of the components in a series circuit are in a sequence following each other. There is only one route for the current to take. The electric current flows through all of the components in turn. Here, the row of bulbs and the fairy lights, until it gets back to where it started from. The problem with this kind of circuit is that if one of the components is taken out or it breaks, the whole circuit is broken and the current stops. Most of the circuits we use every day are parallel circuits. A parallel circuit provides at least two, but usually more alternative routes for the current to flow. This racetrack is like a parallel circuit. There is an alternative route for the traffic to flow. If the cars on the branch of the track were stopped along the branch, the other cars on the main track could still move along. This is the big advantage of a parallel circuit. If components and switches are put on each different branch of the circuit, they can be operated without affecting the other components in the circuit. So if one branch of the circuit is broken because of an open switch or a failed bulb, the current can still flow around the rest of the circuit.
Okay, are you ready for a little bit of practical? I'd like to go around your house and have a look at some of the electrical appliances and see what volt the product is designed for, and then make a note of it. Off you go. Okay, a bit of recapping. Last week your task was to draw scientific circuit diagrams using scientific symbols. If you look at the two on the screen, what you'll notice that both the circuits are more or less the same. The only difference, can you spot the difference? Yes, the only difference is that one has a cell which has 1.5 volt and the other one has a 9 volt cell. Well, there's two cells actually.
What difference does the volt make? What I'd like you to do is, using a pencil and a ruler, I'd like you to draw this chart, and I'd like you to complete the first section, which is prediction. For if you had 0 volt, what do you think would happen to the light bulb? 1.5 volt, 3 volt, 4.5. So you're going to make a prediction.
Okay, so when you add more cells to a series circuit, it means that there will be more voltage, which will equal to brighter lamp. If the batteries are connected in a parallel circuit, then the path of the electrons will split. Some will go to the first battery and some will be going to the second battery. Therefore, the batteries will provide the same amount of energy, so the voltage isn't going to get combined. And because the voltage isn't boosted, we will only get 1.5 volt. And so the workload is going to be split by the two batteries, which will mean that the length will be powered for longer and the bulb will be dimmer.
What would happen to an electric appliance that requires 3 volt if it were powered by 5 volt cell or battery? What do you think would happen? Write your answer down now.
As voltage decreases, so does the brightness, because there is less pressure to force the electrons, so less light is produced. The lamp or the bulb are only rated for a certain voltage and current. If we use a higher voltage, the lamp will become brighter because more electrons are flowing through it, but if we add too much voltage and current, then the lamp will blow up because too many electrons are passing through at once. Okay, so we have come to the end of our science lesson. I hope that you all know what the difference between volt and voltage is, and current, and I hope that you are able to explain the effect of increasing or decreasing the voltage on different parts of a circuit and what the effect is. I hope to receive lots and lots of science work from you all, and I'm looking forward to reading them, so please email it to our Grange email address. Bye.